So today we're going to look at the final way to solve systems of equations, and the final method we're going to utilize is called elimination. So what we do in elimination is we add the equations of two lines together so that one variable cancels. So looking at my system of equations here, first thing I notice is that when I compare my order, they're not the same, right? So we always want to make sure that both equations are in the same order, going x and then y. If they're not, that's step one. So line up the like terms of each equation in columns. Okay, so I just need to reorder my top equation so that instead of negative 2y plus x, it looks like this now, x minus 2y. Now I have the x's on top of each other and the y's on top of each other, okay? Once I have that set up, I need to multiply one or both equations, so sometimes we'll have to multiply both, to make the coefficients the same number, but with different signs, okay? So the idea here is to add the two equations together and one of the variables cancel out. So in order for that to happen, they have to be the same number, but one has to be positive and one has to be negative. So when I look at my system from step one, right, the x's have the same coefficient. Okay, they both have a coefficient of 1, but they're both positive. So to make one of them negative, and it doesn't matter which one, in this example, we took the top equation, and we're going to multiply everything by negative 1, just like they did here, right? So multiplying everything by negative 1 gives me this new top equation, okay? Now, once I have a variable with same numbers in front but different signs, I'm going to add the two equations down, okay? So it's like combining like terms. So when I do negative x plus x, those cancel out. 2y plus 6y gives me 8y. And then negative 8 plus negative 16 gives me negative 24. Okay, now once I have one of my variables cancel out, right? And that is the note here, right? One variable should have canceled. If it didn't cancel, that means we did something wrong and we have to go back and check what we're doing, okay? So in this case, my x is canceled, and I have this new equation, 8y equals negative 24. And now it's easy to solve for y, right? I can just divide both sides by 8, my 8's cancel, and I get y equals negative 3. Now, the final step here, whatever variable I found, in this case we found y, I'm going to plug that variable into one of the original equations. Oh, excuse me. And then solve for the other variable. So in this case, I'm plugging in negative 3 for y. And again, always go back to the original problem. So in this case, we're plugging into the bottom equation. Okay. So plugging in negative 3, I get 6 times negative 3, which gives me negative 18. And then to get x by itself, I just have to add that over to the other side. So I get x equals 2. And again, like we saw in the last video, we always have to make sure we write our answer as an ordered pair. Right? X comma y, which is what they did here. Okay? So let's look at an example. So first step, make sure everything is lined up correctly. So I have 5x and 2x, negative 4y, 8y, 3, and negative 2. So everything is in the correct column, right? Both equations go x, y equals number, x, y equals number. Now, looking at my x's and my y's, right? I have 5 and 2 for my x's, and I have negative 4 and positive 8 for my y's. So I'm going to choose to change my y's. Now, you can always just do the x's if that makes it easier for you. So you'd multiply the bottom by -5 and the top by 2, and that would make the x's the same. But if I look at my numbers, sometimes there's an easier option. And in this case, I would only have to change that top y, right? So I want same number opposite signs. I've already got opposite signs on the y. Now I just need to make both of them 8. So I would multiply my top equation by 2. So multiplying everything on the top equation by 2, I would get 10x minus 8y equals 6. Now I didn't change the bottom equation, so I'm just going to rewrite it. 2x plus 8y equals -2. Now if I look and I start adding up my columns here, right? So we add down. So 10 plus 2x gives me 12x. -8y plus 8y cancels. And then 6 minus 2 gives me 4. Final step, I'm going to divide both sides by 12. And I get x equals 1/3. Okay. Now I need to find the y. So I'm going to pick one of the equations, and I'll just pick the bottom equation, it doesn't matter. I'm going to plug in 1/3 for x. So I would have 2 times 1/3 plus 8y equals -2. Now again, if the fractions are going to mess with you, make sure you're using Desmos. So 2 over 1 times 1/3 would give me 2/3. 8y. Now I'm going to subtract the 2/3. And I would get, I'm running out of room, 8y equals, and then punching -2 minus 2/3 into your calculator, that would give me -8/3. Now, final step, I want to divide by 8. And again, punching that in the calculator, I would get y equals -1/3. Now, generally, we won't give you problems that have fractions, okay? But again, if there are fractions, just use your Desmos calculator, right? It'll do the fraction stuff for you. So my final answer, 1/3, comma, -1/3. Now, attached to these notes are a bunch of practice problems for you to try. Try some of them if you want, right? And bring your questions to class, and we'll kind of go through these problems together. Now, at the top here, if you look, here's kind of the format or the thing we want to say like in our head when we go to try and solve these. So we want to multiply the blank equation, so top equation, bottom equation, by whatever number, right, to make the x or y term cancel. Okay, so that's kind of the process we need to start thinking about in our head. Multiply the blank equation by some number to make the x or y cancel. Okay, so try some of these, and then if you have questions, make sure you make note of it and bring them to class tomorrow.